Hi everyone, today you're going to learn about angle bisectors and also about the segment addition postulate. So we're going to start with angle bisectors today. I put a picture on your note sheet there to kind of give you a visual of what angle bisectors do. And the name pretty much tells us what happens here, but if you look at the airplane, we can see that the measure of angle JKL, this whole angle, is 96 degrees, but you can see this line, or kind of like the body of the plane. There's ray KM kind of going down the body of that plane. That line is serving as the bisector. So if this entire angle is 96 degrees, the one on the left, or excuse me, the one on the right here would have to be half of that. So this would have to be 48 degrees. And again, if it's being bisected, the one on the left would have the same measure. So notice I'm putting matching arcs over those two angles, so that way I indicate those are congruent. Okay, so in this case, this ray going down the center would be called ray KM. And I'm going to put my ray symbol above that. Ray KM bisects the entire angle. And so that would be angle JKM. So there's just kind of a concrete example of what one would look like in the real world. Kind of a bird's eye view of the airplane. And so you probably noticed when we put some markings on the airplane, I used matching marks to indicate angles that were congruent. So if you look at the diagram on the right, the 35-degree angle up here has the same measure as the one down below. So I can put some type of marking, usually it's a curve, to indicate that those are congruent. And then this other set, we could either do like two markings like this. Basically, as long as the angle markings match, you can consider those to be congruent. Okay. I've seen students and textbooks even do like something like this, where there's an arc and then a line through it. Okay. I've seen like stars marking congruency. So as long as they're marked the same, it honestly, it doesn't matter what you use. So somehow mark those with the same markings, and that will indicate congruency. All right. So when you look at the last image on this page, the big idea here is to read the directions. I'm telling you, this chapter, the math is pretty easy. It just comes down to reading directions and figuring out what those words mean. So if I see that an angle is bisected, this word tells me I need to mark something on my paper. Okay, and what I need to mark is that this angle above the ray and below the ray are going to be congruent, because this is serving as a bisector for the angle. In other words, it's cutting it into two congruent parts. And so if you go back to the top of your notes, what does an angle bisector do? It creates two congruent smaller angles. And you can kind of see that here on the picture on the right as well. So somehow when they talk about congruent bisection, you want to mark them as congruent. And also notice that I staggered my markings, and we'll talk about this a little bit more on the next page, but make sure your congruency marks are staggered so it doesn't look like it's one big marking across the entire angle. Okay. At this point, I'm going to ask you, if you haven't grabbed a protractor and a straight edge, to go do that, pause the video, come back, and we can finish watching this after you get your materials. If you've already grabbed those materials, I'm going to kind of pull up my protractor that I can use on the screen and have you follow along with me. Okay. So to start with, just go ahead and draw any type, with your straight edge, any type of line segment, you know, like heading off to the right somewhere. Okay, and then we're going to take your straight edge and draw another side of an angle, kind of heading off to the left. And I'm just putting the arrows to show that this is an angle and it continues infinitely. But once you get your angle drawn and created, you're going to take your protractor and actually measure your angle. So I'll rotate my protractor to make it fit. Notice what I record here is going to be different than what you record. And I will check your packets here in a little bit, so please be precise. Okay. When I have mine lined up here, I can see that it's greater than 90, so it's an obtuse angle. Looks like about, I'm going to say right at 97 degrees. So let's call this angle ABC. And then go ahead and pause the video and measure your angle. Mine is 97 degrees. Yours is going to be different, but I'll record that. You make the adjustment, make the measurement on yours, and we'll go from there. All right, now that you've measured your angle, what we're going to do is we're going to line that protractor back up if you moved it. And I'm going to take my overall measurement and divide it by 2. So in my case, 97 divided by 2 is 48.5. And that number is the number I'm looking for on my protractor, so I can see where halfway to 97 would fall. So 48 and a half, well, here's 45, 46, 47, 48 and a half would be about right here. So mark a point where your halfway value is. Move your protractor out of the way. And then with your straight edge, go ahead and draw a segment from B to, we're going to call this point D. Just use your straight edge to connect that, okay? I'm going to use the line tool because I have that luxury online, but use your straight edge for that. Okay, so to mark these as congruent, draw in 2 arcs, staggered, and I'm going to mark them with 48.5 degrees, but since I've put my congruency marks on those 2 angles, I only have to mark one of the measures, and the arcs will indicate that both of them have the same measure. So the measure of angle DBA, which is this top left one, in my case is 48 and a half. And again, it should be half of your total, and then the other one would be the same on the right side. So the measure of angle DBC would also be 48.5. Okay, raise your hand if you have a question on this drawing, because I will ask to see that when you come up. Might help to stop me now if you need some assistance. Okay, now down below it's the same concept, it's just using algebra. So as I read my directions, I'm going to notice the first thing I see is the word bisect. And just like we did on the front page, when I see bisect, I'm going to mark these angles as congruent. Okay, so that means the measure of angle CBD, this left one here, has to equal the measure of angle ABD. Okay, so this left one equals the right. Well, now it's just a substitution game. CBD, if you look at the picture, is 55 degrees, so I'm going to replace that. And ABD, this right one, we don't actually know the measure, but I know it's labeled as x plus 12, so I can just substitute that in and use PEMDA's kind of order of operations to solve for x. So now that I got my equation written, subtract 12, and we get 43. So x would be 43. I don't want to say x is 43 degrees because really you're substituting a value in to find the overall angle measure. But if we check it, 43 plus 12 is 55. So yeah, it would make sense that these are congruent. All right. 10 is the same way. I will let you try number 10 on your own. So you do this one, and then I would pause the video. When you bring your packet up to me later, not right now, but when you bring your packet up later, you will show that one to me at that time. Okay. All right, now that you've had a chance to finish that question, just a few misconceptions that happen frequently with angle bisectors is students see a picture like this, and since the 50 is written in the bottom angle, a lot of students think 50 represents just this bottom angle. Well, that's not the case, and the reason is if the marking goes all the way across the angle, the number associated with that angle represents how big the entire angle is. So this whole thing is 50 degrees. All right. Notice since there's no staggering on the marks, 50 is the whole thing. All right. Unlike this one, 50 is marked only representing the lower angle. And so all I can assume, and I want you to actually add that marking. That should have been there. All you can assume is that the lower angle is 50. So the measure of angle SQR is 50, which makes this one 50. And it's not drawn to scale, so don't panic. But yeah, this would have a sum of 100 degrees then. In this case, QS, ray QS, is an angle bisector because it cuts this angle into two congruent parts. Down on the left over here, you cannot assume it is. It's not an angle bisector, and the reason we know that is true is because there were no congruency marks on the top and bottom, okay? Had these been staggered, yeah, then we would know that it's a bisector, but if there's just one mark across, you can't assume that it's being bisected, okay? All right, the last topic we're going to look at today is what's called the segment addition postulate, and postulates are really just ideas that we're going to assume to be true. And I'll give you like a real life example. Like you could say the sky is blue. Okay. Now again, there's cloudy days, etc. But generally speaking, we can look up and assume to see a blue sky. Okay. Another postulate might be if it's Monday through Friday, during the normal week of the school or during a normal school week, I will have to attend school. So there are things that you really don't have to prove to be true, but they just kind of exist, and we accept them as true. So postulates are ideas accepted to be true without proof. In mathematics, we use postulates a lot, but you'll see that word. I just want you to understand what it means. Okay, I got two unique pictures here. On the first one, A is kind of hovering in space, and on the second one, B is not. The first one, A is not considered to be between these two endpoints. And I'm sure you can probably observe why, but because we can say this is true. This is true because I'm going to line that up for you here. A is not on the segment that we're referring to. Where B and C live, they have to be on the same segment, okay? Where here, A is on that. So between doesn't mean like it's, how do I want to say this? Between doesn't mean it's like centered in the middle. Between just like right now, A is between B and C. Now, A is between B and C, okay? It doesn't have to be centered. It just has to be like somewhere in between those 2 points. So when it's between, we can say the point is on the line, but doesn't have to be centered. In other words, it not necessarily a midpoint. Okay. And so with that idea, it's a really simple concept. Like let's say this left length is 5 and the length on the right is 7. the entire length would be, well, 5 plus 7 is 12. So the entire length would be 12 units long. So we'll say the segment addition postulate says on this picture, if A is between forgive my pen handwriting here, I'm not by my laptop. If A is between B and C, that's an and sign, sorry. Then, maybe I should go back to my pen tool, or my letter tool. I think I'll do that. Then, oh, that'll work. Then the length of this first segment, so we'll say BA with no bar above it. Remember, no bar above it means length of. So the length of segment BA plus the length of segment AC. So we got the left segment plus the right segment would add up to the total segment, which is called BC. All right, in other words, here we go. It's a real simple idea. Part plus part equals total. Just like we did with angle addition postulate, part plus part is total. All right, so I'm not going to spend a lot of time working through these examples because I think they're going to be pretty easy for you. All right, so a couple things I notice. On this picture, there are no congruency marks, so do not assume that LE is the same length of ET. But since E is between those points, I do know that I can assume that LE plus ET equals the whole length of LT. So let's just kind of mark some things on our picture. So LT is 27. So I'm going to put 27 up here and just kind of draw a bar from end to end just so I know it's talking about the whole thing. Okay. LE is 18. So I'm going to write 18 down here in the center of segment LE. And EX is 3X. So I'm going to write that right here. All right, so we just fill the parts in. LE, they labeled that as 18, plus ET, which is 3X, has to equal the total length, which is 27. So again, basically we're saying part plus part equals total. All right, now we just do PEMDAS backwards. So subtract 18 minus 18, and we get 3x equals 9, which means x has to be 3. So once we get x figured out, now we can just check our math, okay? So here, if x is 3, if I take 3 times 3, that would be 9. Does it make sense that 18 plus 9 would add up to 27? Yep, it sure does. So ET, this length on the right, was 3x, so that was 3 times 3. So that segment would have a length of 9, and you're good to go. Okay. All right, let's do another one down here. RB is the total length, so I'm going to label the whole length. I always do the extension bars. 2x plus 18. Okay. RO is 4. This length OB is 3x plus 5. And so we'll just use our same idea. We'll do part plus part equals total. So I'm going to just copy and paste because I'm doing this digitally. So if part plus part is total, the first part is 4. The next part is 3x plus 5. And then the total length is 2x plus 18. So now we're just going to do a little algebra. I'm going to combine my like terms. 4 and 5 add up to 9. So we get 9 there. I also have a 3x on the left. Sorry, my dog's freaking out because somebody just showed up at our house. Sorry about that. All right. PEMDA's backwards. Let's subtract 2x. Okay, chill out. All right. And then we'll just simplify. 9 equals, or I'm sorry, 9 plus 1x equals 18. Subtract 9, so x would equal 9 if we subtract 9. Divide by 1 still gives us 9. Okay, now the math is real simple. Plug in the x wherever we see it. I'm going to plug 9 in there. Plug 9 in here. 2 times 9 is 18. Plus 18 is 36. Okay. OB is 3 times 9, which is 27. Plus 5 is 32. And I'm just going to check to make sure that these two parts, if you notice those were the smaller parts, they do add up to 36. So that tells me I did the problem right. Okay. Your job, in just a minute, you're going to try this problem. All right. You're going to try that one. Okay, but wait, listen to directions before you try it. When you come up, I want you to show me your planner with these items recorded for homework so you know what you're supposed to be doing either today and or for homework tonight. Show me your planner so you've documented what's due. Also show me the note sheet that you just recorded your notes on, and I will look through the 2 problems that you were responsible for doing. You get in-class points for getting this done. Okay, so bring those items up to me after you get this question done, and then you'll have the rest of the time to work on the directions indicated on your engineering packet that you recorded when you came into class. All right, thanks.